Welcome to the video on our reaction time and distance lab, which can make up both Criterion B and C. So to do this lab, you will follow this link, which opens this document. You'll need to file and make a copy of it so you can edit it. And then you'll begin to move through it. Make a wild guess, make a hypothesis. You can do it in words first, right? Fill in the blanks. What will the distance do and why? And then make a graph. Now to do the graph, double click on this picture, and then you can draw a line. If you think it's a straight line relationship, you can just draw a line. If you think it's one of our curved relationships, I recommend going to scribble here and doing something like this. Now I'm going to keep moving quickly through this video because I expect you to pause and start working on it and then come back to the video or replay something if you are confused. Because I want to keep the video short. So our ultimate lab is going to find the relationship between how does time affect the distance traveled so that we can answer this question about how far this travels in this amount of time. So we've got this game here. This is a stopping distance game. You will hit begin, and then you can change a lot of these variables. You can change the road and the tires. You can change the mass and the speed. But once you decide what you're going to use, keep it the same for the actual experiment, right? Because these are going to be our controlled variables, things that stay the same throughout. The only things that should change are the time and the distance, because that's what we're measuring. Everything else is a controlled variable and should have a value of controls. All right, so you'll play the game, you'll hit start, and then when you see the stop sign, you'll hit break. And this is going to measure your reaction time. So once you do this 3 times, taking down the data each time, you take the data in this Google Sheet template, which again you will need, when you open it up, you'll need to file, make a copy, and then you'll put your first reaction time and distance in. 342 ms is milliseconds, 342 thousandths of a second. So I've set this up so that it will convert for you, 342 as soon as you hit enter. This is a little formula that will convert it to seconds, which is about 1/3 of a second. And then we'll put that distance, 6.84 meters. And then for the stopping distance, and again yours might look different from this because you're going to do it yourself with your own conditions. Stopping distance, you'll have to do the dashes here. So 10 meters, 20 meters, 30 meters. And then each of these dashes is 2 because there's 5 for each 10. So 2, 4, 6, and it looks like about halfway 7. So 37 is our stopping distance there. Sorry, come back here and put in stopping distance. Then you'll just do it again. Hit return, hit start. I want you to do this 3 times where you're hitting stop immediately. Record your data, go back to the lab, record your data, and then write down your average reaction time in our value of controls, because that just gives us a good idea of what your personal reaction time is. So then I want you to do it 2 more times to get more spread out data where you don't hit stop immediately. Let it run for about halfway across the screen before you hit break. And then do it again where you let it run almost all the way across the screen and take those as our 4th and 5th data points. So then we'll copy paste all of this right into our lab, copy paste it here, and we're ready to graph in Desmos. The link is here. You'll put in your time and distance, drag your A, as we always do, until it fits our data, and then take a screenshot of that. Now, if you're on the Chromebooks, we've been practicing screenshots on that. If you're on a PC, Windows now comes with this snipping tool, Start Snipping Tool, and it immediately opens up, ready to click and drag and take your picture. And then you can copy it right here, right-click copy, or you can save it and insert it. There's a lot of ways, and you'll copy-paste this into your lab as well, right? Of course, it'll have data points and stuff, but that's where it'll go. And then you're ready for your conclusion. Now, if there's any part of this lab that you need help on, I have this lab help section here in the lms.pps.net lab help right here. And so if there's any section that you're confused on, you can click on this little arrow and find out more about that section. But I'll give you a little breakdown here. Our claim is our answer to our research question. How does the time affect the distance? And you'll use your graph to answer that question. Our evidence is our graph. You can just say, as you can see in my graph. And then the mathematical model comes from Desmos. We talked about this some, but basically you want to combine which one of these patterns works with the number instead of the letter A. That's your mathematical model. And then I want you to fill in the blanks here about what your A value is, the same as. And you'll check your value of controls and see if you can find that A value to be the same as something else, which will give you an equation that you can then use to make a prediction. The prediction is always the answer to the wild guess question, which you'll be able to use your equation to get an answer to that. Then the confidence, which we haven't done as much. Confidence justification uses this grid right here. Predicted value and the best fit line are our criteria for how confident we are in our prediction. So if our best fit line fits really well, that's going to be some of our higher confidences. If our best fit line goes right through the center of all our data points, or right near the edges. Or if it doesn't fit at all, we're in this low confidence range. Then this one is a little trickier. Is our predicted value within the data range? So you'll have to look up at your data, which will be copy-pasted here out of this, and see if 6 seconds, the time we're predicting for, is within that range, near that range, or far from that range, near or far. And then whichever one of these is true, you'll trace it, and that will be your confidence. And your justification is those two reasons. And then you can do the STEM extension as well about the relationship between reaction time and stopping distance based on this last column. You won't need to graph it. Spoiler alert. All right, well, thanks for watching. And again, go back over this video if you need to, and I will check in with you again soon.